Hello, welcome back to another video about Reflexis Flow. If you've been following our channel, you know that we've started a series of videos about all the new features that we've been working on for our web application platform. And today I'd like to tell you a bit about all the changes to code loading. This may sound like a boring subject, but it's actually one of the things that has given us the most in terms of extra speed and such. So I've prepared an agenda and let's get started. So why talk about why work on code loading? Well, basically because loading code is one of the most, relatively speaking, the most expensive things that the system does. So we're talking about, a Lua-based scripting system, which basically means that code has to be pulled in and compiled and run, and it's exactly this loading of code that takes a fair amount of time, especially if for a complex system like Reflexis Flow there are many different pieces that have to be loaded. So we're talking about system code, flow controllers, flow parts, conduits, type handlers, and these are all separate scripts. So one of the things that I really wanted to optimize and is loading, so fetching this code and making sure that this happens as quickly as possible. Also, I wanted to make sure that code is cached correctly, because previously all the library code that you require, that you pull in through the require function, was cached, but other parts like conduit scripts or type handlers had their own separate caching mechanisms, and this is something I wanted to generalize. So I really want to make sure that code is cached consistently to get the best performance possible. So these optimizations actually meant that we had to change quite a bit of the system's core. One of the things that we started out with is making sure that we had the entire system running on, what I like to call the new style require. So for the old require that we had, the old implementation, if you required a script, it would actually place library functions into global tables, pretty much like the old versions of Lua used to do. Like there's a string table, there's a table, there's an OS table, and functions are placed into these tables and made available to scripts that way. But at some point we realized that it's much better to do this differently, and so we actually changed the system from this old style to the new style that basically works like this. If you require code, you go like this, and with a little luck this is the way you've been always doing things, but the change that we went through is that we actually made sure that none of our library code actually sets these global tables anymore. So you need to make sure that you don't use them and actually require all the codes like this, all your code like this. So, and from here you can use equal, run, etc., etc., etc. And this makes sure that all the library code is placed in a table that you can access through your own local variable. And well, like I said, this is the way we've actually, this is the method that we migrated to, and for the entire system. So we always had require, but we now also have a function called require D, which actually stands for require delayed. And what it does is it implements kind of a just-in-time loading of your code. So it's an on-demand type of mechanism that, well, I can best show you here. This is actually the part that I shown you in one of the previous videos, and perhaps you've already noticed that here this particular library code, web escape, which also some functions for escaping and unescaping strings, wasn't pulled in through require, but through require D, so require delayed. And what it basically means is you get a table, you do get a table, but the table does not yet hold any of the functions. What happens is, as soon as the table is indexed, so as soon as the table is read here, this is the moment that the library code will actually be loaded, and when the function is available for the first time. So why did we add this primitive function? It makes sure that your code is only loaded when it's really needed. So for instance, for this part, the escaping functions, if I here, this is the only place, so if I check this out, this render method is the only location in this code where in this part where this library code is needed. But the render function, well, as the name already implies, is only used during the present phase and the respond phase. But in the process phase, it's not needed, it's not used. So this actually means that require D helps with minimizing code loading. So, and as you can see in this simple button part, the escaping code won't be loaded, won't be required during processing of the step where this particular part plays a part in. And that has actually given us a lot of speed up, because we've started replacing many require calls with the new require D calls, the require delayed calls, resulting in much less code being loaded during many code paths. So it really, obviously it really depends on your code, but for the Flow system and many of the other web applications that we're using, there's a noticeable speed up, so that's really nice. And it's really cheap, because it's fairly compatible with most of your out-of-the-box code, and you only need to add one single letter to the call to make sure your code is only loaded on demand, and it's actually a really big win. It's something that it's an idea that I had when I was working well, it's an idea that I had some time ago, but it's something that we've implemented on a per case basis. Like for instance, I think I had the starter here, and this is something that I used to do. So this code would always be required, and I had two local variables here to delay load code once I needed it. And so this is a starter script for a system that we've built this year. And if you look later on, here further up in the code, it uses constructs like this. So if it arrives at this location in the code, either it has already required the system, or it will require this library code and store it. And the same holds true for the other thing here as well. LVS stands for leaves. And so this approach of loading code on demand with explicit requires and constructs like these is something that I started doing more and more, because there's an obvious advantage to be had. And finally, at some point, I realized that this could be implemented much cleaner and much more generic for pretty much everything, without anyone needing to write these constructs. So that's what require delayed is all about. And what we've done is we've actually updated most parts, so like this one. But if you look at all the system code, all the base parts, they now all use required instead of required, because it gives a lot and costs nothing, basically. Okay. Another thing we've done, speaking of require, is we've added an AutoRequire mechanism, and the AutoRequire mechanism is something that I've added recently, also because we started realizing that for snippets, snippets in flows, we often had this situation of wanting to do something very quickly, like calling this API function or that API function. And since we've moved to these strict new style requires, all the library code had to explicitly be required in all the snippets. And this quickly became a bit of a pain, and it makes your snippets not unreadable, but less readable, because there are all these require calls that you have to put in. So the AutoRequire mechanism basically means that you can now do something like this. So this is a flow definition that that we're looking at. So on the flow level, you can basically add a table like this, and the table can hold 1 or 2 or 3 entries, or many entries like it does here. And so what this means is if in a snippet you're using a global, so not a local variable, but a global variable SQL, it means that the snippet will require the SQL util library and pass it on. So if it uses the LVS global, it'll do the same for the leaves tree code. So if we, for instance, now look at a snippet here, here's an example of how this works. So previously we had to do something like this. Sorry about that. Leaves is require leaves tree, and then we could move on. But now we can leave this out, because LVS is a global in this script. The snippet code, the snippet part will figure out that it maps to a predefined library script. And it will automatically be required for you. By the way, this is another thing that we did. Earlier on, you always had to do this, and this is something that kept repeating itself as well. So we made an exception for DB, and this is basically equal to this here. Yeah. It saves some typing. It's a small thing, but it actually can help. Let's look at another snippet. Yeah, well, it's the same. It's always the same code being required. Well, I was here. So here's this one, and here's a case of the SQL util code being required automatically. So it saves typing, and it can really help. Right. Another thing. So we have a mechanism called the globals monitor. The globals monitor is a mechanism for developers. You can actually switch it on, and it will flag you. It will flag all the access to unknown global variables. So basically, if you've been if you set things up correctly, you avoid any globals in your library scripts, in your parts. By enabling the globals monitor, you will actually you can actually see when something is amiss, when you've mistyped something. Obviously, we also have analysis tooling that'll tell you if you're using globals in your library code or in your parts. But this is that's sort of a static compile time check. So this is a runtime check, and we've actually changed the setting. It's now using the monitor globals setting in your boot script. I'm actually wondering what the previous setting was called. So let's have a quick look. Was it? Yes, this one. It used to be called check globals, but it's from a high level point of view, it's sort of the same. It serves the same function, but the implementation is quite different, and it's more strict, and it's much cleaner and more efficient. So I actually decided to rename it and call it monitor globals to distinguish it. Right. Because of the reworked code loading, and especially because of the caching, we had to rework the packages to make it easier to do it right. So if you know about the packages and building a package using manifest, then you've probably seen that packages used to make a difference between. They used to distinguish between scripts and parts, and also resources, and these would be split into separate tables of the package, because the package is basically a database holding compiled scripts. And to make things easier, we've normalized things, and this actually simplified a lot of things for us. But we've made sure that the package tool still supports the old layout. So there's a parameter, I think it's called -old. So it can still build the old packages, but by default it builds the new packages, and ends up in the item table basically. And another thing that's been changed is that all the names now use full names, so taken from the root of the instance. So for instance, if you have a SQL util, which is a well-known library script, it'll be stored in the item table as lib/SQL/util. And that's basically it. Right, what else? Right. To speed up code loading, we also designed a preload mechanism. I'm not sure how useful it is for production scenarios, but for developer scenarios it can be fairly useful, because the preload mechanism is a mechanism where you can actually instruct the runtime to preload a predefined set of scripts, and this is a very, very, very efficient mechanism, because all the scripts will be precompiled and put in a single file, and let's actually run it. So you can actually do something like the tool's called Flow Preload. And you can actually provide your own list of things that you want to preload, but if you say star, then you can actually see what the default preload set is. So this is the set of scripts, yes, 31 scripts that I've predefined, because this is the code that is most often used in flow scenarios. And but you can define your own list. So, and what happens is that this file here can be placed next to your runtime, and all the scripts that were in your list will be loaded as soon as the runtime starts up. This is actually, again, a really efficient system that can sometimes be useful for developers. Right. We've also added a code loading monitor. So here's the boot script setting, and this can be helpful if you want to minimize loading code. So if you have a lot of dependencies, or if you're wondering, what code is my system loading anyway? Of course, one thing to figure this out is doing a require analysis, a recursive require analysis of your code. And in the past, we've had tools to do this. But this is more of a runtime tool, which makes more sense, because for flow, code is often loaded dynamically, especially now that we have the on-demand require mechanism. So using the new fetch report setting, you're able to see what's actually being loaded, what's actually being preloaded, etc., etc., which sometimes can be useful. Right. And the last thing is, this is something that we're still working on. But I realized at some point that it actually doesn't make a lot of sense to make a difference between application scripts and tooling scripts and library scripts. So the difference right now is that library scripts, if you require them, they don't run, they simply return a table holding their functions. And application and tool scripts, they run at once as soon as they're being loaded. And I realized that this is actually isn't very helpful, because it would be much better to be able to load them and to run them when you want them to run. So this is something that we've been doing, that I've been working on, well, these past few days actually, and to show you what it looks like is it actually here you see many of the library code is now pulled in using require D, but here at the bottom, so this is the flow application script. This is actually the first thing that's called if you're running your flow system. Previously, this was here, flow request, and it would run. This is how things used to look, and this is the way things look now. So, like a library script, and for instance, like parts, if you look at parts, parts always return their table, and their table holds, a number of functions plus some additional information to provide introspection. So this info table holds a description of the part and a description of the various fields. And this is something that we want to do for application and tooling scripts as well. And as you can see, so you might ask, why doesn't it look like this? Why doesn't it simply return the function? And the reason is quite simple. If we return a table, we can extend it. So with this, I can say, okay, this application script has a main function, but it could also have a description, and I could put something in here, and it could have, all sorts of additional information, which would especially be useful for tool script, obviously. That also brings me to another point. I really wanted to make it easier I wanted to provide more automation-like facilities, and for automation, it would be very nice to load a tool and then be able to run it multiple times using different parameters. It's actually something that was already possible. I don't think we ever documented it, but we set up a system a few years ago where there's some magic code that helps you wrap tool scripts, and so you'd be able to have a script that runs tool scripts in loops and whatever. But with a setup like this, it becomes much easier, and you don't need any magic to make it happen. So that's something that we've been working on recently, and it should be finished any day now. Anyways, so this was my talk about all the changes to code loading. Again, much improved caching, no more global tables that you can rely on. Require D, the require delayed function, which is really useful. It's so simple, but it gave us lots of speed up. The AutoRequire mechanism for snippets, that was actually implemented in snippets, by the way, so that's why I opened it here. Another require D. Yes, here it is. Anyways, better monitoring of globals, better monitoring of code that's being loaded, and the changes to packages, as well as application and tooling scripts that are now being made into some sort of library scripts. Okay, well, Not much in the way of demos and such, but still something that I think is important. And I guess now you know about them. Anyways, thanks for watching. We still have quite a few videos to produce, and please look forward to them. Hopefully till next time. Bye bye.